Hey guys, we're going to go ahead and finish section 2.1 today. So last time we met, we finished this example in class and we did a couple more. Today we're going to go ahead and finish the rest of this, and then you should receive another paper from today's sub, so make sure that they hand that to you. Okay, let's talk about midpoint. So the way you're going to calculate the midpoint is you're going to take your lower class limit and you're going to add the upper class limit and you will divide that by 2. Now it's important to realize that the lower and upper class limits come from the same class. Okay, so you're not picking two random ones. Pick a class and then use that class's lower and upper limit, add them together and divide by 2. So, for example, in this example above, right, from the table that we made earlier, we could calculate the midpoint of the first class by getting 155, adding 190 to it, and then dividing that by 2. So we'll get a midpoint of 172.5. Now, the nice thing about midpoints is you only need to calculate one of them, and then you can use your class width, which, remember, the class width of the previous example was 36. We could take our class width and add it to our midpoint, and that'll help us get the next midpoint. So that's a midpoint, and then we can continue to do that to get the next one, and so on and so forth. So all you really have to do is calculate the midpoint of the first class, and then you can use your class width to find the rest of the midpoints. Okay, next thing we're going to talk about is relative frequency of a class. So this is a portion or percentage of the data that falls in a particular class. So what percent of the data falls in a class? So how do you calculate this? You're going to get your class frequency and you're going to divide that by your sample size. Now, the variable we use for class frequency is f, and the variable we use for sample size is n. So in order to calculate the relative frequency of a particular class, you're going to do frequency divided by sample size. Next, we're going to talk about cumulative frequency of a class. So this is the sum of the frequency for that class and all previous classes. The cumulative frequency of the last class is equal to the sample size. So the last class, the cumulative frequency of the last class is equal to the sample size. And remember, we use n to talk about sample size, so I'll write n in here as well. Okay, let's do an example. We're going to find the midpoint, relative frequencies, and cumulative frequencies. And we're going to go ahead and look at the same table that you guys made in the last example, so the one up here. So make sure you have that table in front of you. And we're going to use that table to do this one. So if you haven't done the table, make sure you do that first, and then you can come back to this problem here. All right, so we have the midpoint of the first class. I'll go ahead and do that again. So our table is going to look something like this. So the class, the frequency, and we did all this yesterday. So 155 to 190 was the first class. 3 was the frequency. 191 to 226. 2 was the frequency. 227 to 262. And 5 was the frequency. And so on and so forth. I'm not going to do the entire thing, but you guys get the point. The next thing we're going to add to our table is the midpoint. All right, now the midpoint for the first class, we already talked about how to do this, but I'll do it again. You're going to get your lower and upper limits, add them together, and divide by 2. And we got 172.5 is the midpoint. Now again, the nice thing I said, you can just add the class width, and you'll get the next one. So if I add 36, I will get 208.5. And then I can add 36 again to get the next one. And I get 244.5. And then I can keep going like that. Now, relative frequency is another column we're going to add. So I will shorthand it like this. For the relative frequency, what you're going to do, if we look up here, we're going to get our frequency, class frequency, and divide by the sample size. So in this problem, the sample size was 30, and there were 30 numbers. So we're going to be dividing by 30. So for the first class, the frequency is 3, and the sample size is 30. So we're going to do 3 divided by 30, and that'll give you 0.1 or 10%. All right, let's do that for the next one. Frequency is 2. We're going to divide that by 30, and that'll give us approximately 0.7, approximately 7, sorry, not 0.7, 0.07, and that is approximately 7%. All right, and then you would keep doing that. So the next one would be 5 divided by 30, and that is approximately 0.17, which is 17%. All right, now the next column we're going to add is a cumulative frequency. And we have done this before, especially last semester, but a quick refresher. Cumulative means you're like adding, you're collecting. So within the first class, there are 3 frequencies. So the frequency is 3. So we're going to put 3. Within the next class, there are 2. But now combined, there are 3 plus 2. So now we have 5. Okay. In the next one, now we have 3 plus 2 plus 5. So now we have 10. And that's why cumulative frequency, you're adding, okay? So when you think of cumulative, think of like you're collecting. And you keep going. And the very last class at the end should have 30. All right, so this is how you fill out the tables. Now let's see if we can describe any patterns. All right, because that's what it asked us to do. Just from what I filled out right now, a pattern that you could see, and if you filled out the whole table, you would recognize more, but a pattern that you would see is that this class here is a pretty, we'll call it popular one, right? A lot of the data is in this class. Now, that's only out of these 3 here, right? But that's one thing that we could point out right now. There is 5, half of the data so far is in this class. Okay, because so far we have 10 frequencies, and 5 of them are within this one class. So that's one example. That's really all it means to describe patterns. Just, is there anything that stands out to you? Okay, let's keep going. So now we're on the new section, or the new page of notes. This is 2.1 continued. We're going to talk about a frequency histogram. So this is a bar graph that represents the frequency distribution, the horizontal scale is quantitative and measures the data values. The vertical scale measures the frequencies of the classes. Now, this is important when you make one of these. Consecutive bars must touch. So I will draw a picture to kind of explain what I summarize all this. The horizontal axis, right, which is this one, it is the data values. The vertical axis, which is this one, the y-axis, this is going to keep track of the frequencies. Okay, and then consecutive bars must touch, meaning if I have a bar here and then the next bar picks up where that one left off, you're not going to put spaces like this. Okay, that's a bar graph. We're not doing bar graphs, we're doing histograms, which they're similar, but this is for quantitative data, and the bars also must touch. Right now, obviously, if there's no data here, well, then they're not going to touch there. But that's why we say for consecutive bars, they must touch. Okay. Next, we're going to talk about class boundaries. And because consecutive bars of a histogram must touch, right? We just talked about that. Well, that means that the bars must begin and end at class boundaries instead of class limits. Okay, now if you remember in our table, for example, this one, these classes were built so they do not overlap. However, if I make a histogram using this, class limits, let's say 155 is here, 190 is there, I make my bar, well then the next one won't pick up until 191. So there will be a gap. Okay, this space here is a gap, right? So how do we handle this so that we can inherently move it closer so they can touch like that? Well, that's why we're going to need class boundaries. So these are the numbers that they're still going to separate classes, but they're going to make sure that they do not form any gaps between them. Okay, so here we have the table from the last example. It's still the same table. We're going to find the class boundaries. Okay, so the first thing we're going to do is look at the class limits and see the gap between them. Well, because the gap between the end of the first class and the beginning of the next class, that gap is 1. We're going to half that distance. So 1 divided by 2, and that'll give us 0.5. And that is how much we have to adjust each class by so they can touch. So for example, the first class boundaries will be set to, I'm going to do it right next to it, so I'll throw it over here off to the side. Let's say we have class boundaries. Okay, and this would be an extension of your table. You're going to get both the upper and the lower and extend them by 0.5. So for example, the 155, we are going to subtract 0.5 from. So we're going to get 154.5. And that is going to range to, now the 190, we're going to add 0.5, so 190.5. Now it may not seem like we have done anything yet, but let's do that same thing with the next class. So you're going to get your lower one and subtract 0.5. So that'll be 190.5. And you're going to get your upper one and add 0.5. That'll be 226.5. Now if you notice, where the last class boundary ends, the next one begins. So now if we make a bar graph, they're going to be touching. And that's what we want. And you would keep doing that for the rest of the classes. These are called class boundaries. They're similar to class limits, but class boundaries ensure that the histograms will touch. The bars will touch. And remember, we added 0.5 because the distance between the upper class limit and the lower class limit was 1. And so we just took half of that. So if the distance, for example, between the upper and the lower was, I don't know, 10, well, then we would take half of that, and that would be 5. Most of the time, though, it will be 1. These are set up most of the time so that the distance is 1. And then we half that, and we get 0.5. So go ahead and do that for the rest of the classes. Find the rest of the class boundaries. Should be pretty simple, but get some practice with it. Once we have our class boundaries, we can actually now make our histogram. So there's 2 different histograms that we can make, and I'll draw both of them. Here is the first one. So on the bottom will go our data values. And we can use the class boundaries for this. So our first one is 154.5. The next one is 190.5, and then 226.5. And then you'd keep going. And then on the vertical axis, again, is the frequency. So I'll add a frequency of 1, 2, 3, 4, so on and so forth. If I look at the first class, there is a frequency of 3. So I will make this bar go up to 3. Like that. The next class has a frequency of 2, so I will make this bar go to 2, and now you notice that they will be touching. Okay, and then you can write the number in there if you'd like. And go ahead and finish the rest of this histogram. Now there's another way to make this same histogram. The only thing that would change is the x-axis. Instead of using the class boundaries for the x-axis, you can also use the midpoints. And this is also very common. So the midpoint of the first class is 172.5. The next one is 208.5. And then you'd keep going with all the midpoints. And same thing. the frequency of the first class is 3, and the midpoint was that. So I'm going to go ahead and extend that first bar all the way up to 3 and bring it back in. And because this is a midpoint, this tick mark should be in the middle of the bar. Okay, the next frequency was 2. So I'm going to go ahead and go up to 2. And then now I kind of did a bad job, so let me fix this. You want to make sure that the bars are of equal width and that the midpoint is actually in the middle, like that. Again, you could put the numbers in there, and you would finish this histogram with the rest of the midpoints. So there's 2 ways to make a histogram. You can either use the class boundaries or the midpoints. If you ask me which one I prefer, I like the class boundaries, but midpoints is pretty common, so you have to be able to look at both and create both. All right, let's go ahead and keep going. Now a frequency polygon, this one's pretty easy. This is a line graph that emphasizes the continuous change in frequencies. Okay, so let me go ahead and show you what that looks like. Okay. We can also use class boundaries, or we can use midpoints for this. Let's say that we're actually going to use midpoints. So the midpoints, these are all the same example, by the way. So this table and this table, they're all pretty much the same thing, the same data set. So if I create an X and Y axis, and I label all the midpoints, so the midpoints that I have here, I have 172.5, 208.5, 244.5, and then you keep going. You're going to go ahead and keep track of the frequencies using a line graph. So the first class has a frequency of 3, so we will go up to 3 and place a dot there. The next class has a frequency of 2, so you go to 2, place a dot there. Next class is 5, so we'll go to 5. The next one would be 6. Go up to 6 like that. And then you'd connect everything from left to right. So, like this, using straight lines. And then you would keep going until you finish. Now, this is very important. You notice how this line graph did not start at 0 on the x-axis? So what we're going to do is take our class width and extend this. So we're going to subtract 36 basically to get the previous class limit. And it's not going to have any data, so we're going to go ahead and go 172.5 minus 36. And we're going to get 136.5. Now, the reason we're doing that is because, obviously, there is no class of 136.5. Because there is no class, the frequency there is 0, which means that we can start at 0, and that's actually what we always want to do. So we always want to extend back a class, so we start at 0, And same thing on the other side. If I were to finish this line graph, whatever it's going to end up looking like, if it doesn't end at 0, and it's not, right, extend that also one class width so that it does end at 0. So with these frequency polygons, you should always start and end at 0. And we do that by extending one class width over to the left and one class width over to the right. All right, let's keep going. And we'll do more practice when I return to class tomorrow. Relative frequency histogram. This has the same shape and the same horizontal scale as the corresponding frequency histogram. So this is a relative frequency, which means decimals or percentages, but it'll be the same thing as a frequency histogram. The only thing that changes is the vertical scale, because instead of the vertical scale measuring frequencies, now it is measuring relative frequencies. All right, so it's going to look something like this. Down here, we're still going to have the data values, but on the y-axis, now it'll be relative frequencies. But it's the same idea. So let's make a histogram. We can go ahead and use class boundaries or midpoints. We have the class boundaries, so let's do that. 154.5, 190.5, 226.5. Now remember, off to the y-axis, it's going to be relative frequencies. So we're not going to use these frequencies. We're not using these frequencies. We have to use relative frequencies. So remember, that's where we do 3 divided by 30, 2 divided by 30, 5 divided by 30, right? So those are the numbers that we're going to be plotting. So for the first one, it was 10%. So if I label this, I could either do 0.10 or 10%. I'll do 0.10. And that first bar should reach 10% or 0.10. So I will extend it like this. And then in there, if you want, you could write 10%. The next one was 7, I believe. So we're going to go to 7, like that. And then you keep going like that. Now you'll notice the shape, although I didn't draw it the best, the shape will be the same as this one. The first one's taller, the next one's not as tall, right? Same thing here. The first one's taller, the next one's not as tall. Same shape, it's just the y-axis is now percentages or decimals. The nice thing about this is that you can see the percentages and quickly identify how much data is within that boundary relative to the rest of the data. All right, we're almost done. Now we have a cumulative frequency graph or an OGIV, and this we did see last semester. Except we didn't call it an OGIV, we just called it a cumulative frequency graph. This is a line graph that displays the cumulative frequency of each class at its upper, very important, upper class boundary. The upper boundaries are marked on the horizontal axis. So the x-axis. The cumulative frequencies are marked on the vertical axis. So here are the steps to making an OGIF, or a cumulative frequency graph. Construct a frequency distribution. So this is one of these tables that we're making, right? So make a table, but you want to make sure that the table includes cumulative frequencies in one of your columns, because obviously we're going to need them. Then you're going to specify the horizontal and vertical scales. Okay, very important. The horizontal scales consist of the upper class boundaries, not lower, and not the limits. It has to be the boundaries. And the vertical scale measures the cumulative frequencies. Then you're going to go ahead and plot the points that represent the upper class boundaries. Again, it has to be the upper ones, not the lower, and their corresponding cumulative frequencies. Then you're going to go ahead and connect the points in order from left to right. The graph should start at the lower boundary of the first class. The reason for that is because at the lower boundary of the first class, the cumulative frequency is 0, and we want to start at 0 for this type of graph. And when we finish, it should end at the upper boundary of the last class. And there, the cumulative frequency is equal to the sample size. So in the example we've been using, it'll be 30. All right, let's go ahead and look at this example here. We have our data right there. This is our frequency distribution. We made sure to include cumulative frequency there because we're going to need these numbers. And we made sure that we have our upper class boundaries. This is the same example that we've been doing for the whole video. Okay, remember, you're going to start not here. You're going to start at the lower class boundary for the first class. The lower class boundary for the first class was 154.5, so that's where I'm starting. The reason is I want to start at 0. Okay, off to the side here, we have cumulative frequencies. So this here. The next one, it will be 190 now. Next one will be 226.5. Next one will be 262.5. And now we just plot everything. So the cumulative frequency at the first one is 3. The cumulative frequency at the second one is 5. And then we go to 10. And connect them left to right. Now, I'm not going to complete the rest of this, but you should get something that looks like this. It'll keep going up and up and up, maybe not in a straight line, but like that. And that is how you construct a cumulative frequency graph, or an OGIV, as we are calling them in this class. But yeah, that's it. Make sure you guys complete these examples. I know I only did about half of it, but take the time to complete them. And tomorrow when I get back, we can check our answers and make sure that everything was done correctly and ask any last minute questions.